Hi, guys. This is the HackerNoon podcast. Today, we have a special guest with us. His name is Juan Benet. He is the founder of IPFS, Protocol Labs, and guys in the cryptocurrency space. They know him as the founder of this big company called Filecoin, which I guess everybody knows. They raised 200 million plus dollars in 15 or 20 minutes. This was one of the biggest success stories, and that, I guess, in my opinion at least, led to a whole flurry of ICOs coming one after the other, trying to cash in on what like Juan Bennett has been doing. We also have with us Wasa, who is a HackerNoon contributor. He is one of our top writers in terms of what is Web 3.0, and like he has been leading the HackerNoon narrative, at least in terms of what the power of decentralization could be. So, without wasting any more time, I would let the guest of honor, Juan Bennett, to take the lead in terms of introducing what he has been doing. And I guess like once he starts going, like it would be hard to stop him. So like let's start with that.
Hey, thanks for having me. It's a pleasure to be here chatting with you guys and the entire HackerNoon audience. So I read out a number of posts from HackerNoon, so it's great to be here. And yeah, in terms of what we've been up to, so Protocol Labs builds a whole bunch of different systems and protocols, things like IPFS, Filecoin, libp2p, and others. Each of these protocols and projects is advancing in its own has its own kind of growth trajectory. Lately, we've been very focused on two things. One is the kind of the growth of IPFS and the major improvements that are coming down, and so things like the whole range of new applications are now using IPFS either just to kind of store static assets or embedded or are shipping with IPFS embedded within itself. And so just being able to kind of scale the network and work with all of those adopters is one of our big areas of focus. And then the other is building out Filecoin and getting to the Filecoin mainnet and shipping. This has been probably one of the most kind of awaited things in the cryptocurrency space, and we're pretty excited to be super close to mainnet launch. And we've been running multiple test nets, amassing a whole bunch of capacity with a lot of miners around the world, and we're getting pretty stoked about releasing the network. And so that should go live. Kind of like our current target is around end of July, early August. That's sort of where we're targeting. Of course, software, right? Like there could be, this is like best estimate, could be a little bit later, but yeah, we're super stoked about both the capacity in the network. We're going to have way more storage than we know what to do with. It's going to be an amazing time for application developers because they're going to be able to put all of the stuff that they've been doing with IPFS in terms of like building applications that address a whole bunch of data on Web3, and then move all of that to fully be stored not on Amazon S3, but now on a proper crypto Web3 native decentralized storage network. So that's going to be pretty exciting. And then we're also pretty excited about the implications of making a decentralized storage market. Like the moment that you create a marketplace where anybody can add capacity, and because of kind of where they are and how close they are to users and so on, gives them a competitive advantage for being the storage provider for a set of users. Like that has never really been like before blockchains, like that wasn't really possible. Nobody has ever done this, and so we're pretty excited to see what happens when you can have a proper market structure come into kind of cloud storage, right? So today, hard drives are commoditized, but cloud storage is not commoditized. And we're super excited to see what's going to happen when the ability to kind of do engage into kind of storage contracts and so on with people around the world becomes an extremely easy thing to do. So yeah, there's a lot coming this year, a lot of exciting developments across the stack from all of the new applications on IPFS, pushing Web3 forward, Filecoin, and also lower layer protocols like libp2p. So that's has become one of the foundational things in the Web3 space, where a lot of different now blockchains are using libp2p for the networking layer. So this was a project that was refactored out of IPFS. So we tend to do this thing where whenever one of our systems gets kind of big, we break it apart into subsystems and sub projects and so on. And we did that with LibPP and very successfully. And now it's become kind of like the main base networking layer for the entire blockchain space, and that's been pretty amazing. Groups like Polkadot, which just shipped, adopted it. Ethereum 2 adopted LibPP. There's a whole host of other users like Keep and ZeroX and a whole bunch of others. So that's also maintaining those systems and improving them is what we've been up to. So a lot, but yeah, it's an exciting year.
It's nice to hear all of these things. Like, it's nice to hear, and it's a refreshing change in terms of like what we keep hearing in the cryptocurrency and blockchain space. And now we would move over to Vasa, whose real name is Vaibhav, and like he has been one of the key proponents of Web 3.0, IPFS, libp2p at HackerNoon. He has over 60 stories published over here, and he has contributed to IPFS, OrbitDB, Ethereum, Quorum, and many more. And I would like now let him speak a bit about like what he has been doing and like what he thinks about Web 3.0 from a developer's perspective. We have a perspective of the founder, the guy who like made it, and now let's like hear like what the developers are saying. Over to you, Vasa.
Cool. So, hi everyone. My name is Vaibhav, also known as Vasa on the internet, and I'm a IT undergrad working in Web3 space since 2017, and I've been running startups since 2018. So, I've been contributing in uh, many projects like IPFS, Ethereum, MobiDB, Quorum, etc. And I've been contributing to HackerNoon since like 2018, and through that time, I've seen HackerNoon grow from HackerNoon 1 to HackerNoon 2.0, and that has been like really good transition from moving from Medium. And currently, I've been working on a project called DAppKit. So DAppKit is basically Firebase for Web3. So the problem with Web3 development here is today is that like we don't have any structured way to approach this Web3 development, because like there are a lot of tools here and there and different stacks that are emerging out. But if I actually come as a new developer from Web 2 and try to build a web application on like using Web 3 stack, it would take me around like a month or two to actually build an application that is something that I can show to the users. So we have been trying to solve this problem, that how to make uh, developers to build an application in like within a day or something like that. So we have been working on this since November last year, but I have to shut it down like for a few months due to my college work, and I resumed it in April. And since then, we have been growing pretty fast with around 200 GitHub stars in less than 2 months. And apart from that, I have been writing a book with Springer Nature on data analytics and mining. That's it. That's me.
Nice to hear that. Nice to hear that, Vaibhav. And like, best of luck to both of you guys. So, like, now we would get started with the core of the podcast. And I would like to start with addressing the elephant in the room. Like, there are people who believe in blockchain, bitcoins, and cryptocurrencies, and then there are people who do not. And on the side of people who do not, they have this very strong argument that it is not scalable, there is no mass adoption. And the way I see it is that they forget how long it took for the internet to take root. It was built by DARPA in the 60s or like maybe in the early 50s, like who knows the exact dates. Like, and it took them, it had to cross that dot-com boom and that dot-com bust where everybody thought that the internet was like done for. But so they were very, I guess, lenient towards the internet, and they should have been more lenient towards, uh, let's call it, our side of things. So I wanted to like know from you, Yuan, it's like, how do you answer these questions to people in terms of like, where is the mass adoption? How do you like answer them? Because you are like building things 24/7, like practically
Yeah, totally. So, I think like nothing could be more wrong about this space in terms of the future, right? So I think about this in two ways. One way is you actually, if you look closely, there is a lot of massive adoption. You just have to. It's not on the surface because it's not as fast as other things, right? So I think everybody's gotten used to things like social networks that grew super fast. And things like Facebook went from 0 users when it got started in around 2004 or something to then billions within like I think something like 5 or 6 years, maybe a little bit more. And so that kind of growth is super fast, and so people have grown to expect that kind of super fast growth. Especially things like Instagram and others also grew up super fast, WhatsApp and whatnot. But I think that kind of growth is specific to social networks or social media where you have this extremely high viral coefficient. If you don't have systems like that, the growth rate of most of application technologies and so on is a lot slower. And when you think about it with that lens, cryptocurrency and Web3 is growing super fast. Like it's around it's very similar to other kinds of things. Like think about the cloud, right? So people think about the cloud as really kind of appearing 2007, 2008, and so on. Like that's when things started like really blowing up. Maybe 2010 or 11. I don't remember exactly when Heroku came out, but like people think of that as the cloud era. But in reality, the cloud started in 2000. Right in the middle of the height of the boom, there was a company called LoudCloud. Ben Horowitz started this, and that was Ben Horowitz and Mark Andreessen and a whole bunch of other folks. But that era of computing kicked off the entire cloud development that then later we saw 5 to 7 years later. Um, and even at that time, the word cloud had already been around for 5 or 6 years. So computational platforms take a while to develop, something on the order of 10, 15 years. And we're in that trajectory. The Web3 and cryptocurrency space is like on track. And I think looking at the numbers helps. Nowadays, we're at a point where the Web3 world has on the order of 50 to 150 million users. I think that's roughly like the size. It might be a bit bigger, but that's an estimate based on things like the number of users on Coinbase and other kinds of systems. So Coinbase has 30 million users alone. Think about every other exchange, every other wallet, every application. And this is without touching kind of some of the now nascent Web3 native applications which are starting to pick up steam. So the important thing is to look at the growth rate. How fast are these systems growing, and what is that adoption rate? And I think within it's not as fast as social networks yet. I think once we have native social networks in the space, we'll see kind of this meteoric super viral rise. But other than that, like all kinds of applications are getting adopted, and that growth is pretty steady. So both by looking at the raw numbers, it's in a really good spot, and by looking at kind of like the trajectory of application platforms in general, they take about this long. And to your point, the internet, got started as a research project, took a very long time to kind of get developed. The web, even the web felt super fast, and the web numbers were in the low millions. Like when everybody was writing about the web and like this crazy new thing and so on, that was in the low millions of users. So the entire Web3 and cryptocurrency space is massively, is much larger than that. It's just that nowadays we're so used to the internet being an everyday thing that if things don't, grow as fast as social networks, then they don't feel like they're growing, but in reality they are.
Uh-huh. That's an interesting argument that like people tend to like compare everything to social media like networks growth, and if it is not going viral, then they get skeptical. This is nice. In terms of
Yeah,
social,
in our case, like we see like the growth of IPFS, for example, as like at least 10x every year. And so, if we can sustain that growth, in a few years we'll have billions of users, or like billions of devices.
definitely this is nice. And when we speak about IPFS, this like we have to like think of it is how the mainstream media sees it. Like if I talk about like the closest example that I have is one of my favorite examples. It's from this show called Silicon Valley, where they tried to build the decentralized internet. Like although I loved the show, But the portrayal over there, like they were on the cryptocurrency side of things, there was a 51% attack mentioned. I wanted to know what's your take on things. Like, did they overdo it? Because those guys are brilliant. Like, they got Silicon Valley spot on. Like, they know
Yeah,
what's.
yeah. I thought this was great. We really liked seeing that entire thread of stories, and we were chatting with the writers and so on as they were kind of writing the shows. They reached out to us and a few other organizations to kind of like ask about things and how it worked and so on. And it was fantastic, like chatting with them, like super brilliant group. They totally understand Silicon Valley. They totally understand the blockchain networks. They totally understand the movement. What I really liked about that entire plot line, though, is that it brought a ton of attention to the real problems, right? And so with the show gave enormous amount of lift to the problems, to the ideas, to what's actually going on. And so now it's way easier for the entire Web3 and crypto space to talk about what we're doing, because now there's a very common reference point where a ton of people have watched those shows and understand what the problem is about. And so, it really went from like, I remember this sort of happening because we sort of felt this inflection point between it being hard to explain what we were doing, and it kind of being like, well, people would kind of liken it to BitTorrent or liken it to Git or things like that. And then as soon as the plot in Silicon Valley started, everybody picked up and like, oh wow, like the Silicon Valley show and like all of these organizations and so on. And that became much faster in terms of people understanding what these systems ended up doing. And so I think it's net positive. I think it was really good that they did that. Really good to draw attention to the problems. And they got a lot of stuff super right.
That is right. And like, here's just like small thing. So I was speaking to like Andrew Levine, who like used to be the head of like advocacy at Steemit and now is with Hive, building his own blockchain now.
Yeah.
So like, he said that his parents called him up, and because they'd been like watching Silicon Valley, they were like, we finally understand what you do. So it's nice. So now we'd like to like get into some like tougher questions in terms of like IPFS and like the question of censorship. So there are like two aspects to it. Like, we need to regulate certain things and we need to have a freer press as well. So like, who draws the line within the IPFS universe? At least I know that it is decentralized and like you guys can speak more about it. But I would like to know from you guys, it's like, where would you draw the line? Like, who polices what is right and what is wrong? Because clearly some things are wrong and some things are wrong in a particular context. Maybe some things are wrong according to certain laws. So who manages all of that? Like, is there a governance layer, or like, how do you like guys plan to take care of certain questions so that let's say kids are not exposed to certain things?
This is a key question for all of the internet, and this is not just for things like IPFS, but for all of the web and all internet protocols. The way we think about it is this: we think that human rights need to be able to be digital as well, and so things that the internet. So if you think about computing and you think about the rise of computing and how quickly we've gone from things where like there were huge mainframe rooms, and now we are carrying around in our pockets, right? So it took about 80 years to go from the ideas of computers to now everybody's walking around with like a supercomputer in their pocket that they can do all kinds of amazing things with, right? You can call everybody, you can stream to the whole world, you can send messages to any person on the planet, you can be part of a public conversation, you can tweet at presidents of nations and ask them, hold them accountable for things and so on. The level of connectivity that we have today is truly fantastic compared to what we had before. And those kinds of superpowers come with a really important dependence on making sure that the technology respects the rights of people that are engaging with it. And so the hard part is that even as a civilization, we don't agree on what the right things or wrong things to do are, right? Like this is important to have. It's important to have like a different points of view. It's important to try different experiments and to let different groups make different choices about what's going on, right? So what's right for one group might be wrong for another group. And the important thing there is agency. Those groups need to be able to have the agency to decide what happens in their networks, right? So if one group of people thinks that distributing a certain kind of content is bad, they should be able to collectively, as a group, decide not to distribute that content. But that decision shouldn't be made for them by a different group, 3,000 miles away from them, that has nothing to do with them. And so it's very, very important that the computing technology that we all depend on does not kind of turn against us. That the decisions about what is good or bad aren't made by people that are not us, right? So this has to be a system that puts user choice at the center, and that really shifts the power dynamic to make sure that humans interacting with the computers choose the how things should work. And we've embedded that kind of thinking across the stack. So we think that there shouldn't be kind of central policies that, kind of like a botnet that command and controls all of the nodes to do something, but rather that the nodes should default to have things like block lists, where, hey, if you are in a particular country and you need to follow a particular set of laws, you should follow a block list associated with a particular set of laws, and not distribute or download content associated with that kind of in a particular way. But that's different from a different place, right? So, for example, there's some things that everybody or a lot of people in the world agree is really bad, but there are other things where that's not so clear cut. So think of the right to be forgotten. So this is like a very controversial thing where in some countries, a number of governments have decided that, and kind of, by popular opinion and so on, have decided that being able to remove your public presence from the internet is an important right. And this is very controversial because in other places, people point out like, hey, that's wiping away history. That's allowing people to get away with bad things and then kind of change the historical record, so to speak. So there's good disagreement about this, and we have countries choosing different positions. And what you need to have is an internet infrastructure that allows different people to decide what they want to do and what rules they want to follow. And so you should have same defaults, but you should also give people the ability to opt into or out of these kinds of rule sets, and for them to control their computing, right? So we, like in the open source movement and in free software and so on, we think that technology should serve their users, not that technology should control their users. And so that's a very important dynamic where if you were to build an internet platform that just embedded control and gave that control to some other parties, then imagine how easy it could be for people to take control of that system and then cause all kinds of bad things to happen. So, and we happen to live in a very fortunate time in history where our biggest problem right now is like this global pandemic and some potential tensions, but we don't live in a period of major global war, or we don't live in a period where hundreds of millions or billions of people are being kind of persecuted by in the middle of a war or genocide or something like that. Now imagine if a government took control of the internet infrastructure, and suddenly all of your phones that were giving your location at every all the time and to these central powers could then choose and decide who to go after and so on, right? So think about like all of what was very striking about the Snowden leaks was that the ability, and this was not really that much of a surprise for computer scientists, because we all understood that this was possible. We all understood how much information these devices leaked and how much information these devices traced and so on. But what was useful about that entire moment was getting everyone in the world to realize that this kind of mass collection is going on all the time by a lot of different governments. And that is not just like your government that knows what you're up to, it's every government. And at that point, letting kind of like this kind of war scenario between different governments take place, controlling your device and spying on your communications and so on is something that like I really think that the technology and the computing platforms that we use should build strong shields against that and should protect users from that kind of attack. And so to your point is like it's really about user agency, being able to decide what future you want to be part of, and being able to choose what rule sets you follow.
Got it. Got it. And I would like tend to agree with that. That technology should be an enabler. It is like what we say in the uh, medical side of things. Like we say that you have a scalpel, and it's totally up to you, like whether you choose to let's say slice someone or maybe perform a, a surgery with it. So yeah, it makes sense. Now we'd like to move over to like what you have been doing like personally, in terms of like we'd like to know more about what's going on with Filecoins. Like you guys have this mainnet launch coming up in July, and what are the expectations over there, and more importantly, it's like what is your uh, benchmark of success for a lot of these other organizations? Just raising the money was their benchmark of success. Now they are like nowhere to be heard of. So like I would like want to know from you is like what do you think is going to be that particular KPI that you say, okay, once I get this, I'm going to say that IPFS, Filecoin, they have become successful. And what is it that is like going on over there?
Yeah. We're getting ready for launching the mainnet, which includes finishing up the implementation of the Filecoin nodes, getting building all the tooling that miners need in order to provide a good service, building. There's a whole set of kind of layer 2 solutions that need to exist around making retrieval fast and allowing kind of application data to be structured in a way to embed into and store into Filecoin. And so we're pretty busy with most of that development. And this is not just Protocol Labs, but now it's a whole host of different organizations. Now we have a pretty large ecosystem with two or three dozen different groups that are coming together to build all of these tools and technologies. So groups like Textile and ChainSafe and Suramitsu and Fleek and a whole bunch of others that are coming together to build all of the different pieces of tools that are required to build out this ecosystem. And so that's the main focus. It's just getting all of the tooling for miners and developers and users ready. Once we are there, there's a whole bunch of testing and validation that we have to do. Launching a blockchain is kind of like launching a rocket, right? And so you have to get a lot of things right. It's an extremely complicated machine that where some vulnerability here can be pretty problematic. And things don't blow up like in rockets. Like with a rocket, something goes wrong, it blows up. With a blockchain, it's not quite like that, but it can cause this failure mode where you have to like restart things or the network is down briefly or something like that. And so getting all of the testing and validation up front to make as robust and dependable of a system as we can is really important. One of the other things here is like the scale that we're going to have is much bigger than most blockchains have at the beginning. So we have to get ready for a lot more, meaning compared to other blockchains when they started, we expect to see a ton of activity mining right away, and we have a mining community that's super amazing that is putting together tens to hundreds of petabytes of storage and getting it ready to go in the network. And so that kind of scale is just unprecedented in any blockchain system. And so we'll see what happens there. Like we have a much higher bar to clear. And so we want to do as much as we can to test out things as we get into that. And so that's the main development. Now, in terms of what are the metrics of success, so at the end of the day, Filecoin is about storing user data, right? So it's users and applications come into the Filecoin network and store their data in the network and hire miners to back up their content and serve it later. So one important metric there is that the number of deals and like the number of the amount of data that's being paid for by somebody to be stored. Another important metric that is common to all storage services is things like uptime and things of the speed of retrieval, the making sure there are enough copies of data around so there's no data loss, things like that. There's a whole host of kind of network health monitors that are important. But again, like to your question about KPIs, it's really about how much useful data and how much value is being created by the Filecoin network coming together to kind of provide the storage service for end users. And we sort of expect a a ramp up period, right? So all of these kinds of networks have to first get going, and so we don't we expect sort of the first few months to be really testing out and exercising what's possible in the network, meaning a lot of the users that we're focused on getting early is groups that have either large data sets or want to kind of push the limits of this kind of network to test it out. And we see the first, say, 6 to 12 months of the network's history as building up the capacity, doing all of the hard optimization work of tuning like the parameters to make sure that the network is working really, really well, collecting a ton of metrics, finding problems, debugging those problems, making it a really, really good network. And then we see kind of the period after that as then turning around and saying, okay, great, we've amassed this great capacity for storage. Now let's go and try to store all kinds of incredibly important applications. So we sort of see the first 6 to 12 months being a really, really good period for new developers that want to understand these systems and want to get started and want to figure out what's possible in the platform, make some early prototypes and early versions, and start iterating with their users. And groups that have huge amounts of data and they want to see either like a really large cost reduction, or they want to get better properties about their data. They want verifiability and all that kind of stuff. And so for them to kind of try out the network and for them to kind of exercise it, that'll be good. And so that's kind of on the client side. And now on the miner side, that's where this is a really exciting year. Like just joining the network and providing storage capacity, setting up your racks, learning how to mine Filecoin, optimizing your own setup, your own systems, and so on. That's again kind of like this first 6 to 12 months is going to be a really great time for those groups to get started, and really all around the world, right? Because a thing that's very different about Filecoin mining versus say Bitcoin or Ethereum mining is that because Filecoin mining is providing useful storage, it kind of really important matters where the storage is. So a client coming to the network is going to choose to store data in, say, a few different regions where their users are. And they also want to store the data close to them. And they might want to have copies in different continents just in case something bad happens. And so, you might store a copy of something in Asia, you might store a copy of something in America, you might store a copy of something in Europe. And so that means that even though at the very beginning of the network, the mining power might be in some area, it'll get diffused out over time to match the demand of the users. So the user demand is going to drive the existence of miners in a bunch of different locations. And so we see that as like an extremely exciting opportunity for people that want to get want to earn Filecoin by providing storage to just get set up somewhere. And just because maybe there's a lot of power in another country doesn't mean that you can't be one of the top miners in your area.
Got it. And like, I would now move to the final question of mine before we move over to the web side of things. It's like, I think of the world being divided into two sorts of people. One of them are cloud positive, people who are like pretty much okay with their data on the cloud. And then there is this other side of like people who are cloud negative. It includes my wife, the person who like drew this. So she does not like use any cloud solutions. Like she does not use Google Drive, she does not use Dropbox, neither OneDrive, because she believes that her privacy is at stake. She doesn't believe it. With IPFS, I guess, because all of that data is diffused, she might believe it, she might not believe it. And because she's young, so like maybe she will believe it. But what about people from a generation before us? Like, how do you answer their privacy questions in terms of like, how does IPFS and the decentralized web take care of these privacy issues?
Yeah, great question. So the most important part here is to make sure that we move the world to not just having kind of end-to-end encryption in the wires, but to have user-controlled encryption, where a user gets to decide what kind of you need encryption that puts the user in control, right? And so the user needs to have the keys. They need to decide who to share things with, and a service or application should not have the ability to look at your data, right? So a lot of the cloud solutions that we have today, so things like that you mentioned, things like Dropbox and so on, store your data in the clear in the cloud. And so that means that they can look at what's going on. And so that means that because they can see what you have and so on, like that kind of it's really difficult to trust those kinds of systems. And I would agree with her that right now there's just a tremendous, terrible privacy violations across the world happening because of this. Like you have this massive collection of information and so on, and it's not just privacy, it's security, right? So you right now we, again, like we were saying before, right now we live in a period of peace relatively in the world. What happens if suddenly governments, bad groups, or take control of governments, and suddenly a country that was actually really enlightened and governing things really well suddenly goes bad for a while, and during that period they take all of this, all of the keys to this super powerful spy machine everywhere, and they start kind of targeting groups based on what they've written in their own notes or their private diaries or whatever. Like that's crazy, but that's a possible future that we might live if we're not careful. And so I think in this period of time we have some ability to shift computing platforms to a system that puts the user first. So user first encryption, think about it that way, where the user is in control of the keys, and they get to put everything. They get to decide who gets to see their content and so on. And this isn't just for your personal files, but this should be for all your applications, right? So this includes, documents that you share with other people, like, think of like a Google Doc type of thing where you collaborate on something, or it could be like family photos or companies' documents, or all of that stuff should be kind of by default only visible and viewable by the people that own those pieces of information, not by the application developers. And so shifting this is going to take a lot of hard work from a lot of groups. We're helping to push that forward, building a lot of the kind of underlying technologies that you need, but there's a lot more that needs to be done on top of that. Like today, you can get started with this. You can try out, say, Textile is a group that's been developing a lot of different sets of tools on top of IPFS, and one of the things they have is textile threads and textile buckets, and they're working on all of the access control issues there to make it so that you can write an application that stores data on IPFS, and but puts the control and the user encryption on the hands of the users, and not kind of on the application developer. And that's a very important shift once we have all of that kind of stuff working, and a lot of applications can start using that mode. Then we might see a cloud world where putting your information and your data on the cloud does not also mean giving all the application developer, the storage provider, and all of these groups access to view all your content. So it's really important to say that like diffusing the information is not enough. Not only do you have to like not collect in one place, but you have to encrypt it in a way where only the user has control of the key.
Got it. Quite insightful. I'll let you know like what my wife has to say about that. And with that, I'd like to move the baton over to Vaibhav and like take over the technical side of things.
Yeah. So like just pointing out what discussion that we were having is that one insight that I have is that about maybe 20 or 30 years ago, at that time when we didn't have that much penetration of internet in the world, like usually the privacy breach was considered that like I get a detective and like throw it at you. At that time, like if you're sitting in a room, then like you will be pretty much safe. But like today, maybe like, when even we are like surrounded by we are not surrounded by anything, but still we are leaking a lot of data. So like in terms of user perspective, like this is a main problem that we actually can't see that we have been robbed of the data. But like 20 or 30 years back, it was much easier to see that someone is like spying on you. Yeah. So like we have been talking a lot of stuff about Filecoin. Let's move on to IPFS. So cool. A few months ago, I think IPFS launched a 0.5 release, and I wanted to like in terms of comparing 0.4 and 0.5, what what are the enhancements, and like what features that does it provide that enhances the user experience or the developer experience?
Yeah, so so we had our 0.5 release earlier in this was like the late April, so it's been about a month almost. And the main thing there was performance. So we focused really hard on a lot of the user feedback that was coming in through a bunch of different channels. So this is application developers, this is individual users, infrastructure providers, and so on. Like all the different, there's a bunch of different communities that use IPFS in a bunch of different ways, and they were they constantly give a lot of feedback through GitHub and surveys and so on. And the kind of the number one thing that people were asking for was a whole set of important performance improvements around, say, content discovery and content distribution. And so we focused on that, and part of that ask came from the network scaling a lot. So we saw about like 30x growth in the network size during 2019, and so that whole growth meant that a whole bunch of solutions that worked before at smaller scales started breaking at larger scales. And so we needed to, as a whole community, come together to make a bunch of improvements and optimizations in a bunch of spots. And so things like we improved kind of things like adding content, finding content, fetching the content, and so on. And then we focused very hard on kind of the speed of discovering content and serving it out to end users, right? So we run one of the HTTP to IPFS gateways, and so we get to see a lot of the traffic that kind of goes through that gateway. We get to see like the metrics associated with that traffic, where we can see how long it takes for some of that content to be found or served and so on. And so we wanted to get down what was taking kind of like tens of seconds down, and we got the average down to around 6 to 7 seconds for some content, and now a lot of content that's kind of well connected now down to like 2 or 1 second, and so like that's getting a lot closer to the delivery kind of experience that you expect out of a Web 2.0 sort of world, where it's not quite a CDN speed, so CDN speed is not there yet, but it's getting close to, say, things like S3 speed, where like really the target is around 300 milliseconds to 1 second. Like that's where we want to get to. And so this whole 0.5 release was about speeding up that whole range of things. And so yeah, we're super happy with the results. Like there's a orders of magnitude improvement in a bunch of areas, and several factor improvements in others. Speeded up file transfers, adding and so on. It also comes with a ton of features. So things like support for TLS. We finally brought TLS to IPFS and upgraded the connections there. We also improved Quick, and now that's going to become the default. We had a whole bunch of important UX improvements, so things like subdomain gateways, so that you can isolate the origin with a web browser. Things like peer, the ability to kind of like manage the connections better and manage peer sets better and so on. Like there's a whole bunch of things there that people had been asking for a while that we got in. So yeah, it's been that period from 0.4 to 0.5 was quite a while, and so we put in that accumulated a lot of different changes. And so yeah, it's been really good results so far, and a whole bunch of folks that upgraded to 0.5 just saw the immediate improvement and benefit in all their applications.
So getting into the specifics, in terms of speed of DHT and IPNS, what sort of fraction that we are looking for in order to actually see significant improvement in the speed? So like, is there like 50-50, or like what's the fraction that we are looking for? So like, just to be clear, in terms of if a lot of, yeah, cool, like go ahead.
Yeah. So I think right now, so IPFS got to start using a DHT for content discovery. And so this was like an okay solution to start. But DHTs aren't very good at larger scales. So kind of the intention from the beginning was to swap out the DHT with a different content discovery or content routing mechanism.
Yeah.
And we're kind of like in the latter stages of getting the most out of a DHT, right? So DHT, because of its structure, you end up doing log n hops through the routing table to find
Yeah.
a node, to find a content, right? And so that means that if each one of your steps includes kind of round trip times to other nodes in the network, and those nodes are potentially far away from you, you might see somewhere between 10 to 100 milliseconds of latency in each one of those hops. If the network is millions of nodes large, then you're going to have
Okay.
10 to 20, 10 to 13 different hops, and each of those are going to be stacked up sequentially. So the speed that you can get out of DHTs is going to like push it into seconds for content discovery. Content routing to a different mechanism, something closer to what cloud systems use, which is they have indexing services that kind of collect a lot of the kind of pointers of who has what content and whatnot and where to find it, and so make sure that when a user is trying to find the content, they get like sub-second delivery. And so that shifting the world from using a DHT to using those other mechanisms will take some time and it'll take some work. It's not really clear what we should use yet, because there's a whole bunch of important resilience properties that come from using a DHT that you don't get in other systems. So this is an interesting period where we have a bunch of proposals in mind and a bunch of different potential systems. A lot of other things kind of get suggested. We'll see how this develops and how the community wants to move this forward. But we know that unless we make drastically better DHTs where you can get kind of high churn in the tens of millions of nodes coming and going, and kind of like close to O of 1 delivery, like sub-second delivery, which is basically no DHT really does this ever. Unless we can do that, then we know that a DHT is not the right solution.
Sure. Cool. So speaking of 2019, in 2019, the main focus that, like in terms of user cases, IPFS focused on package managers. And what is the specific use case that IPFS is focusing on in 2020?
Yeah, great question. So in 2019, we oriented around package managers because we thought that that presented a really good use case of having kind of like large binary assets and kind of a distribution model that lent itself well to IPFS. So we did a lot of kind of performance improvements for those use cases. We set up a lot of relationships with different package managers. We a bunch of user studies and kind of segmentation of the different kind of use cases that different package managers need, right? So because there's a lot of different package managers. There's things like software library and code package managers. There's binary package managers for things like Linux distributions. There's app stores, which are a version of package managers. They're just kind of moving binaries within kind of a walled garden. There's like game distribution systems, which are also a different kind of package managers. There's all kinds of like all kinds of stuff, and so we did a whole bunch of studying around all of these different groups and kind of what they needed and so on, and we kind of prioritized a few really key important performance improvements for those groups. This sort of coincided with like large growth in the network and a whole bunch of other things, and so we got somewhat far into that goal, but we haven't completed it by any means, and we saw that the same set of improvements that package managers needed were also kind of the things that container distribution things needed as well. So a lot of the work that we did for package managers and that we're doing now for it, and it is kind of benefiting a lot of the container distribution things as well. So we're likely gonna so kind of the results achieved there include a bunch of important performance improvements for those groups, and then some important pilots and attempts at testing it out for this kind of flow. But there's, I think, a few set of features missing there to really enable a whole bunch of package managers to really adopt. I think what it really requires is the work that's actually going on right now with Nix, which is it requires a group that's dedicated, that understands the distribution model of IPFS and understands the package manager really well, and them developing the tooling that they need to kind of shift things forward. And so I think once we are able to close those gaps, then which is kind of community driven. There's so much that you can do push, you also have to get a pull from the other side. And so we're super stoked to work with groups that want that kind of distribution and want to work with us to make it happen. So again, like the set of folks who are working on the Nix package manager to do this is exactly the right kind of way to do it. And so for 2020, after kind of collecting a lot of the feedback through 2019, we then decided to focus on performance. So that's why the kind of focus for this year has been entirely around improving performance in a bunch of different capacities, improving the kind of release flow. We ended up creating a whole new project to test this, which is I think called Test Ground, where we ran into like hard problems in terms of testing out the network, and we needed to be able to test the network with thousands of nodes across regions and trying to get like realistic network conditions and so on. And so we built a project to test out peer-to-peer networks, and we call it Test Ground, and it's available for anybody to use to test out their own systems. And we use Test Ground to drive a lot of the performance improvements that we're seeing now. So we needed to do a whole bunch of that work to get to the point where we can now start testing out all of the how the features and optimizations and so on that we're doing, how that is playing out for the use cases.
Cool. So you mentioned about the containers and like package managers. So Protocol Labs has been working with Netflix since I think 2019 after the IPFS scam, and I think like can you explain us about what specific improvements that Netflix has seen with this collaboration?
Yeah, totally. So yeah, after IPFS Camp, we started a really great collaboration to really figure out how IPFS can improve the developer tooling experience for a bunch of the kinds of things that groups like Netflix do. And so this was really awesome work from folks over there who and there's a blog post. It's a great blog post that kind of details this whole story, and you can read from Edgar there, who drove a lot of this work, which is about looking at the distribution model of a peer-to-peer network and using that in the cloud. In a data center to accelerate the distribution of container images. And this can also apply to package managers and to VM images and everything like that. And there's been kind of systems like that in the past. And so the work there was really to see, how much can IPFS and this kind of tooling benefit that particular use case. And we've seen that like that's super useful. Like you can see the benchmarks in the blog post. So IPFS outperformed the Docker Hub by a long shot, and kind of the Titus registry, which is Netflix's solution, which is way much faster than Docker Hub, was also kind of outperformed by the peer-to-peer solution that Edgar and other folks built. And so that's also the good thing is that that work also drove improvements in IPFS itself, and we improved BitSwap and we improved the content delivery there. So it's a really amazing win-win for everybody, for all of the IPFS community, for Netflix, for other groups, to look at this kind of developer tooling use case and test it out. So I think it'll be a while before all of this stuff kind of enters production use by Netflix and other groups. So this is still kind of trying things out, optimizing flows, seeing how good it is, and so on. And so we'll see over the next year how that translates into production use with any group. We're not sure about how that's going to play out, but it looks like super promising and optimistic. Especially, this is like an amazing area for the audience and hackers out there. If you're interested in developer tooling and you're interested in making the distribution flows much better and much faster, if you've ever been annoyed by like trying to install a package and having it wait for a while, or ever been annoyed by the fact that like you're trying to download packages that are either in your computer already or in a computer next to you, and you're like, why am I connecting to the internet somewhere really far away and downloading something really big when the data is already like either in my computer or in the next room? And so with IPFS, you can make the distribution much better, much faster. It's just that in order to, there's a whole bunch of like important feature sets that need to get built out for that to happen. And so if people want to do hacks around this, I think that's a great area to start.
Yeah, so like just extending what you have mentioned, like let's suppose we put the IPFS nodes on the mobiles, like that's sort of resource intensive and kind of loses your battery. You tend to lose your battery really fast. But let's suppose we have Netflix using IPFS in their apps. So like, what do you think can be the challenges, and what are the things that will improve
Well,
significantly
so
with this P2P
IPFS
structure?
doesn't have to waste your battery at all. Like what's going on there with like some early experiments is that people took kind of like a desktop distribution of IPFS, which makes a lot of connections and does a lot of kind of crypto handshakes and so on, and just put that directly on the phone. And so doing that, yeah,
Yeah.
it's not optimized for the phone. It's not going to work very well. But you should look at the work that OpenBazaar did for Haven, or Audios has done for their platform. They run full nodes
Yeah.
in mobile phones, and they don't waste battery, right? Like they work fairly well. The applications are super smooth. You don't even notice that this is a peer-to-peer application at all. Like it's really kind of amazing what they've been able to do in the last year. And that was a bunch of important optimization and improvement work that made it so that you can do this. Now, in terms of like kind of media distribution, yeah, we think that using IPFS to distribute video and so on can be super good. And like the use case is it matches the use case very well. The yeah, there's a couple of groups that are already doing this, and so we hope to see like what develops over time. In terms of like groups like Netflix and so on using it, not sure. I think it's going to go into developer tooling first, right? So I don't think that
Yeah.
Netflix is planning to experiment with that at all right now. It's more around developer tooling and improving the flow for developers, and having successes there might translate in the future to then adoption in applications or in the video distribution and so on. But that's kind of like a ways out. That's like I think a few years out, because that kind of
Yeah.
you have to consider that something like Netflix has had 15 years of optimization on the delivery flow of that, and so being able to kind of and they already
Yeah.
have like a whole massive fleet of machines all around the world that do this content delivery, and so competing with that is pretty difficult. Where IPFS could really shine
Yeah.
is for new groups that don't have that kind of systems built out, and that's where say the kind of infrastructure provided by cryptocurrency can really help, right? Because if you write your application with IPFS and you distribute things on with IPFS, say like a video application or whatever, and then there's a bunch of Filecoin miners near you, then they can store the content and serve it to you really quickly. And so that's the kind of world that we're going after and that we're building out. But it'll take a
Yeah.
while to get there.
Cool. So IPFS has a grand vision to replace the HTTP protocol, or you can say like at least go hand to hand. How far does the Opera integration of IPFS like takes that vision forward?
Yeah, so that's been a really amazing result that we've seen this amazing adoption with browsers, and so this is latest Opera, and before that Brave, and there was also an extension for Chrome and Firefox. So the really amazing result with getting this integration with Opera. So what that enables is around like 200 million users or more are now able to access IPFS directly from their browsers natively without having to install anything else. And like that is an amazing improvement. And that doesn't mean that 200 million people are using IPFS that way. It just means that their browser is enabled, and that if they find links on the web that point to IPFS content, they can now view it. And so that's like an amazing leverage point for then going to larger and larger, more mainstream browsers. So that's where we're super stoked about the really great work that that Opera did there, and kind of like the next step from there is thinking about integration into a whole bunch of other browsers, ideally by running a full node directly with the browser. That'll take longer, it'll be more work, but what's really amazing to me is just how we got to this place just within kind of so quickly, like building protocols that are able to distribute the web content is extremely difficult. There's the history of protocol development is includes a whole bunch of systems that try to do this. Things like SCTP and others that really try to improve the distribution of content, and weren't able to get a kind of adoption like this. So it's amazing that so quickly we got major browsers like Brave and Opera adopting IPFS and enabling the content for all of their users. That in my point of view, like that would have taken something like 10, 15 years, and it happened around around 5 years after like the inception of the project, which is super fast in kind of browser development timelines. And so we hope that that this is gonna just pick up steam, and that a lot of other groups are gonna start adopting, and it's gonna get into a whole bunch of other browsers. So really great work from Opera and Brave and others to help bring IPFS as a proper first class citizen of the web.
Cool. Utkarsh, you can proceed with that.
Perfect. So I guess like we are nearing the 1 hour mark, and we'd like to let you guys do what you guys do best. And I'd like to end with a small question as to like, what does your high level roadmap look like?
For which project? For IPFS, for Filecoin, for everything?
For you, like what do you plan to do over the next couple of years?
Oh, so I mean, I'm personally super focused on the growth of IPFS and Filecoin and the P2P. So it's really like each of these projects has its own kind of roadmap and trajectory. They intersect somewhat, but they kind of have their own paths. And so I'm just super focused on that growth. And for that, it's say for IPFS, it's now getting into doing all of the kind of work around application development and private content and all of that work that we're talking about, and kind of speeding up the adoption also with so it's really kind of crossing the chasm from the Web3 world out into the mainstream. So IPFS is widely used as like the #1 thing in the Web3 space, but we now want to make Web3 expand to be as big as Web2 and eventually larger. And so that is going to take a while to do. And so that's our big goal is to how do we get how do we make it a lot easier for developers to get started? How do we make it a lot easier for large scale applications to use these tools? There's a whole bunch of important developer tooling that we have to build to get all of that adoption to be possible. And so that's a big focus is looking at these really amazing applications that are getting built right now and helping them grow. So applications like Audios and so on. And also looking at developer tools like Textile and Fleek and a whole bunch of others, and helping them grow as well. And then also thinking about the kind of like ecosystem of businesses and services around IPFS. So things like pinning services and so on, and naming systems. So there's things like ENS and unstoppable domains and others that are making it super easy for people to add websites and point to IPFS content and so on. It's amazing, by the way, like how easy it is to get a crypto domain now. It's like easier than a normal domain name. It's super good. Like I was making a website the other day, and like it was just so much easier to get a crypto domain and use that than the normal DNS. And like that to me is like an amazing sign of the times changing. And so there's kind of my focus is around all of that stuff with IPFS, and then with Filecoin, it's launching the mainnet, building out the capacity, getting the first few waves of users and adopters, learning a ton from that, improving the system and the protocols through that, and kind of scaling it up in the long term.
Got it. Thank you very much, Juan. And like you have the best wishes from the HackerNoon family, our 6 million plus readers, and like people who like pretty much enjoy and like are on this like cusp of this change, because this generation that would be succeeding us, they would be more adept at like using their own private keys and whatnot. Because I have this saying, like for people in my generation, you don't really understand blockchain unless you have lost a few private keys. The next generation will not have those problems. So like, yeah, we are counting on like you guys to make sure that the next generation has more fun than this one.
Yeah, the UX just has to get better. Like people shouldn't be losing keys. Like that's a product problem. That's not like a user's learning thing. That just the products have to improve. And yeah, I think if I could leave the whole community with a couple thoughts is, hey, if you're a hacker and thinking about building your next project and or looking for cool ideas, drop by our community. So like drop by GitHub or drop by Matrix or Slack or all of these different. We have a bunch of different rooms in these platforms. Come and hang out and come chat with the community. And there's a bunch of really cool ideas floating around. And there's also like depending on the idea and so on, if it's something that the community really wants, there's also some grants available there where you can help improve the tech for everybody else. And if it's something that the community has put a grant on, you can also earn money that way. And also, I want to plug. We're doing this hackathon in July called Filecoin Ignite that it's going to be tuned around kind of early users and early entrants to Filecoin and IPFS and so on. And so we're going to have a whole bunch of learning material and learning content, including tutorials and workshops and presentations and so on, for people to get started and learn a ton. And there's going to be kind of prizes at the end of the month for the winners of the hackathon and so on. So if you and a team of folks are super excited about Web3 and crypto and so on and want to get started building, come join us for that.
Awesome. So what I'll do is that I'll take all of these links from you, put them in a HackerNoon post and share it with the entire community.
Awesome. Sounds great.
Yeah. So I guess
Thank you.
I should let you guys go. Thank you for taking the time out for us, and thank you for being on HackerNoon. Thank you, Yuan. Thank you, Vaibhav. Have a nice day, guys.
Take care.